Users are very likely to try a chatbot or other virtual agent. But unless their experience is positive and the chatbot solves their problem, the user is very unlikely to give it another chance. So it's extremely important that chatbots are effective and provide the promised experience. So how do we automate testing of chatbot performance to ensure this? Our approach is to develop a framework to test chatbot robustness by comparing divergent input examples to the original input and analysing the results to highlight weaknesses in the bot. This feedback can be provided to developers before deployment, allowing them to test their bots to ensure they meet performance requirements before they are rolled out to customers. So the user interacts with the chatbot through Skype by typing in their queries like they would to another person, as shown here. As you can see, the bot completed the first task perfectly. But failed to understand the intent of the user's second utterance. In this case, it may have been quicker for the user to just check their calendar. Chatbots are designed to be used by humans, so input is likely to be unstructured and noisy. For example, there are many ways a human may phrase a query with the same intent and entities. Never mind common mistakes such as typos, spelling errors, or conjugation mistakes.
So this is how our testing framework works. So first, you assume that you have a chatbot, and your chatbot is able to understand and to answer some queries from the users. So those are called utterances. And to every utterance, you would have a response given by the chatbot. Our system tests the chatbot by using some generating techniques, a series of divergent examples. Each of them doesn't change the semantic or the pragmatic or the intent of the original utterance. So we assume that the responses are the same as the original one. What we do is that we compare those new responses to the original one, and we get a performance indicator of how good, how robust the chatbot is to those modifications.
The output of these tests is a robustness figure, which can be used to benchmark chatbots and improve chatbot performance before deployment. A challenge we have faced is that the divergence themselves must also be tested. When we compare the bot's response to that of the original utterance, the derived robustness figure is only accurate and meaningful if the divergence maintained the same intent as the original utterance. This project is in its infancy, and there's a lot of work to be done, especially in the areas of intelligent divergent generation and intent validation.